Okay, so to start off with, when you're doing these types of problems, you need to know the chart as far as like which one goes first and then next and then last, so you know how to derive and anti-derive them. So the first one you'll start with is acceleration, and it's written x of t or s of t. And that doesn't really make sense because it would make more sense if it was like p of t, so you knew it was position, but this is just how to do it. And then the next one is acceleration, or velocity. So it goes v of t. And then the last one is acceleration, and it's written a of t. So when you go from one problem to another, and you want, like, let's say instead of position you want velocity, or instead of velocity you want acceleration, as long as you're going down the list, you will derive the problem to get the next equation. But if you want, let's say you're going up the list and you want velocity instead of acceleration, or position instead of velocity, you will anti-derive the equation you're given. So an example would be if you're given the position equation of, say v of t is 4x, or x of t is 4x squared plus 32x plus 30, and you want v of t, you're going to derive that, so it's 16x plus 32, and if you want to go all the way to acceleration, you'll just have 16. So deriving it is pretty simple. When you anti-derive it, so let's say we have a of t equals 32x. So, or it's just 32. And so let's say you want velocity, you'll have 32x, and you have to tack on a plus c, because you don't know what might have been there before it was derived. So it's kind of like a placeholder, and then when you get into the harder stuff, and it will ask you to find c, because it actually factors into the problem. And let's say you wanted to go all the way to x of t, you'll do a second antiderivative, so you'll have 16x squared, and you'll do cx plus d, because again you have to have a placeholder, and you have to add an x onto the c, or otherwise it wouldn't have been there to begin with.